Hi everyone. In this version, the world started to look and feel more alive. New creatures appeared, the first parts of a future food chain appeared, and under the hood there are now more systems that are needed for a big simulation. Today I'll show what changed on screen, and then we'll look at the architecture behind it. How NPCs search for resources, how they react to threats, why everything gets expensive fast without a special index, and why optimization starts not with guesses but with metrics. The main visible part of this version is the rabbits and wolves appeared in the world. A rabbit here isn't just a decorative picture, it's already part of the needs system. It can look for water, look the food, wander, react to danger, and try to get away from a threat. The wolf is the next step toward a food chain. This still isn't the final hunt, but the base is already there. One NPC can be not just a nearby object for another NPC, but a threat, prey, or a source of future resources. And from this moment the world starts getting more complex, because a rabbit looks for water or a wolf looks for a rabbit. Sounds simple, but in a big simulation it immediately raises the question: how do we search fast? How do we avoid checking the whole world every frame? How do we avoid killing performance, and how do we avoid turning behavior into chaos? It's very important that a wolf hunting a rabbit shouldn't be a granted win for the wolf. The wolf is dangerous, but the rabbit shouldn't be free food. In most cases, the wolf will lose the chase not because it's weak, but because the rabbit has its own ways to survive. The rabbit starts moving faster, turns better, can quickly change direction, and often stays not far from its burrow. If it notices the threat early, the wolf has very little chance. So the hunt should depend on the situation. The wolf wins when the conditions are good for it. The rabbit is far from cover, notices the danger late, chooses a bad direction, or is already in bad shape. What I care about here isn't arcade logic, like the wolf saw it, the wolf ate it. I want a small game drama between detection, a quick burst, a turn, and the attempt to reach cover. A naive hunt is when the wolf just runs to the rabbit's current position. But if the rabbit is moving, that position gets old very fast. The wolf will be chasing not the rabbit, but the place where the rabbit was a moment ago. So later, the wolf should try to run not to the prey's current coordinate, but to a predicted intercept point. It should take into account the rabbit's movement direction, its own speed, the prey's speed, and the rough time to close the distance. At the same time, the wolf doesn't have to calculate the math perfectly. Mistakes are even useful here. The rabbit can suddenly change the direction, the wolf can lose a good angle, get tired, or give up the chase. But the basic idea matters. Hunting isn't just moving toward the target, it's prediction. When the wolf catches a rabbit, or later, for example, a deer, the victim shouldn't just disappear. A dead body appears in the world, and a dead body is already a new resource provider. For the wolf, it can be meat. For people, it can be meat, hide, bones, and other materials. Later, hides and bones can be used to make items, tools, clothes, or other things when the matching systems appear. But a dead body shouldn't be an endless container of fresh resources. it spoils. Right after the hunt, the meat is fresh. Then the quality goes down. Then some resources become useless, and different creatures can trade spoiled food in different ways. Some can eat carrion, some can't. This is an important point for the ecosystem. The death of one creature doesn't just remove an object from the world, it changes its role. Rabbits and wolves are only the beginning. When I think about animals in the game, I don't want to just add new animals for the sake of quantity. An animal should bring a new role to the ecosystem or to the gameplay. If one species already covers the role of small fast prey, I don't need to immediately add 5 more almost identical small herbivores. If the wolf already covers the role of a strong predator, the next predator should work differently. Otherwise, we'll get a set of different sprites with the same logic, and I need an ecosystem where every species has a reason to exist. For wildlife, the starting core can be built so that every species covers a separate niche. Rabbit, a small herbivore, is fast prey, a food base for predators, and a good sign of the state of grass, bushes, and local safety. Deer, a large herbivore, is more valuable than a rabbit, but it's harder to hunt. For a wolf, it's better prey, but also riskier. For a human, it's meat, hide, bonus, and maybe antlers. Fox, a small predator and a thief. It can hunt rabbits, steal chickens, and avoid wolves and humans. It's not a strong enemy. It's a source of problems for a settlement. Wolf, a medium or large predator. It hunts rabbits and deer, and when hungry it can switch to riskier targets. Farm animals, a fox, or even human. In a pack, wolves become more dangerous. Bear, not a copy of a wolf, it's a rare, strong, omnivorous territorial threat. It can eat berries, honey, fish, and carrion, attack when hungry, or defend its area. Boar, also not just one more herbivore, it's an aggressive omnivorous pest. It can ruin crops, eat roots, acorns, and waste, and when threatened, it may attack instead of running away. Domestic animals cover not the wild niche, but the farm niche. Cow, an expensive asset. It gives milk, meat, and leather, but it needs food, water, and protection. Pig, not just one more source of meat. It can turn waste and a cheap feed into food. Chickens give eggs, meat, and feathers. They connect the settlement with wild nature well, because they become a target for the fox. Sheep matter not only because of meat. Their main separate role is wool, fabric, clothing, warmth, and trade. Horses aren't food first. They are transport, plowing, carts, and mobility. For the world's economy, this kind of creature is much more important than just one more animal on a pasture. Dogs are countermeasure against threats. They can guard, follow people, help with hunting, and warn about danger. Cats cover a small but useful niche, protecting storage and food from mice and rats. Not every creature has to be a full NPC right away, with the same level of behavior as a wolf or a rabbit. Rats and mice aren't a copy of the rabbit. Their niche isn't the field and it isn't grass. Their niche is settlement, storage, and supplies. They spoil food, can spread dirt or disease, and immediately give cats a reason to exist. Fish carries the water niche, and the start it can be not a separate NPC but a resource of a body of water. Fishing for people, food for a bear. Bees give a strong farm connection without overloading the simulation. A hive can give honey and wax, affect plants, and attract a bear. Scavengers and crows can appear later. They react to dead bodies, trash, fields, and leftovers. This makes the world feel more alive and gives a visual signal. If birds circling somewhere, maybe someone died there. This approach helps avoid making the animal list too big too early. For example, goats aren't needed yet if we already have cows and sheep. They can return later if they get a separate purpose. Mountains, poor pastures are low maintenance. Ground squirrels, and many types of small herbivores also aren't needed at the start. The role of small wild prey is already covered by the rabbit. One more deer-like animal isn't needed, while the deer covers the role of large, peaceful prey. And we need to be careful with predators. The wolf covers a strong predator. The fox covers a small, smart predator. A new predator should give a different mechanic, like the bear. In the end, we get not just a list of animals, but a network of links. Plants feed rabbits, deer, and domestic herbivores. The rabbit becomes prey for the fox and the wolf. The deer is more valuable prey for the wolf and the human. Chickens attract the fox. Storage attracts rats, and rats give cats a reason to exist. A herd can attract wolves or a bear, and dogs and humans become protection. Fields can suffer from boars and birds. This already looks like an ecosystem. Every new species adds links, risks, resources, and behavior. And once we start thinking in these kinds of links, it becomes clear why serious infrastructure is needed under the hood. We need a spatial index to quickly search for resources, traits, prey, a herd, storage, a hive, or a dead body. We need providers, because one object can be a source of different things for different creatures. We need caches and dirty flags, because we can't recalculate this whole network every frame. We need perception profiles, because a wolf, a rabbit, a deer, a dog, and a human should see, hear, and sense the world in different ways. And we need tests with invariants, because a system like this can easily break not in one place, but at the connection between several layers. Now let's talk separately about the visual part. In this iteration, I decided to improve the picture a little, so the video is nicer to watch not only for developers but also for players. Before this, many scenes looked like a technical test stand. A map, test objects, debug logic. That's enough for checking algorithms, but for viewer, it's important to see at least a hint of the future game. So now there is grass, surface textures, and tiling. This isn't final art, and it isn't the final style. It's a step toward making the world feel not like a dry grid, but like a game space. Another small visual change is NPC flip by direction. Right now, it's a basic version. If a character moves right, it looks right. If it moves left, the sprite is flipped. Later, I can add separate up and down directions and then maybe diagonal directions also. Then NPCs will read better during diagonal movement and when reacting to the environment. This isn't only cosmetics. In the future, facing direction can be connected to perception. What the NPC sees in front, what it sees from the side, and what it almost doesn't notice from behind. The next important layer is perception. Right now, the easiest way to imagine perception is a circle. If an object is inside the radius, the NPC sees it. But for a living world, that's not enough. Different creatures can have different vision shapes. For example, a deer can see well to the sides, worse in front, and weakly behind. A rabbit can have a wide view, but the back zone can still be worse. A wolf, on the other hand, can see well forward because it's predator and it chases a target in front of it. So in the future, the check does the NPC see the threat should take into account not only distance but also angle, facing direction, creature type, state, and environment conditions. So the logic shouldn't be only this. Threat is closer than the radius. But closer to this, the threat is nearby. It falls into the vision sector. It's visible enough for the species, and there are no conditions that make detection much harder. For the wolf, an important perception channel can be not only sight, but also smell. The wolf doesn't have to see the rabbit with its eyes right away. First, it can find a trail by smell. Understand, the prey was recently somewhere in this direction. Then it follows the trail, adjusts the direction, and only closer to the target switches to visual contact and pursuit. This makes hunting more interesting. Sight answers the question, who do I see right now? Smell answers the question, who was here recently and where could it have gone? And this is connected to architecture again. Smell isn't just an effect. It's world data that appears, lives for some time, gets weaker, can go into the spatial index or a separate structure, and then disappears. Now, let's look at how an NPC searches for something in the world. If a rabbit wants to drink, it needs to find water. If it wants to eat, it needs a suitable food source. If a wolf is nearby, it needs to detect the threat. If a wolf is looking for prey, it needs to find a possible target. On a small test, we could just loop through all objects, but with thousands of agents and a big world, this approach dies fast. So a spatial index is used. Important objects registered in the structure organized by space. The NPC doesn't ask what exists in the whole world. It asks what is near me within the radius. Resource providers register themselves in the spatial index. A bush can be a food source. Water can be a source for thirst. A wolf can be a threat for a rabbit. A rabbit can be prey for a wolf. A dead body can be a source of meat, hide, and bonus. The same world object can change its role. A living rabbit is part of behavior. A dead rabbit is already a resource provider. When optimization starts, it's easy to say, Let's add a cache, but a cache by itself doesn't solve the problem. First, we need to understand where the data source is. In my case, the object and its components are the main state. They store a position, type, traits, and role in the world. The spatial index is a derived structure. It shouldn't become a separate truth about the world. It stores a useful view for search, where the object is, which chunk it is in, and which traits can be used to find it. If we don't separate this, we get nasty bugs. One layer thinks the object has already moved away. Another still sees it in the old place. A third makes a decision from data that should have been updated. So, for optimization, the important thing isn't only the cache, it's the chain of data ownership. Who stores the source state? Who updates the derived view? Who sets the dirty flag? And who reads the ready cache? If a system has a spatial index, provider caches, thread caches, and separate system passes, we can't rebuild everything every frame. For this, we need dirty flags, change flags. If an object didn't change, we don't need to register it again and move it between structures. If the position changed, we update the spatial index. If the object's role changed, we update the trait other NPCs use to find it. If the object disappeared, we remove it from the index. This way, we don't recalculate the whole world every frame. We update only the changed parts of the data. Now, an important point about the frame budget. If we target 60 frames per second, we have about 16.6 milliseconds per frame. And this isn't the budget for the rabbit or one wolf, and not only for NPC intelligence. This is the budget for the whole game. Input simulation, pathfinding decisions, rendering, UI, debug overlays, and service systems. So we can't do everything directly in the main frame and right away for all NPCs. Some work is calculated every frame. Some work is spread across the budget. Some work goes into queues. Some work runs only by dirty flag, and heavy tasks that fit this model well can be done in other threads. But multi-threading isn't magic. If we just move house into a nearby thread, the system won't automatically become good. We need queues, a work feeding policy, and load control. When optimizing, we can't look only at average FPS. Average FPS can look fine, but the game can still slaughter. The reason is that some frames can go far over the budget, so we need frame time metrics. How many frames fit the budget? How many didn't? And where the P50, P90, P95 and P99 percentiles are. P50 is the typical frame, the median. P90 shows heavy frames. P95 is closer to visible drops. P99 often shows spikes that the player feels as micro freezes. For a simulation with many NPCs, the important thing isn't only the normal frame, but also the tail of the distribution. If P50 is good and P99 is bad, it means the system sometimes creates expensive spikes. In optimization, you can't trust intuition, and you can't even trust yourself. The brain often sees not what actually slows things down, but what looks suspicious. I may think the problem is in pathfinding, or in rendering, or in the spatial index, or in NPC logic. But until the profiler confirms it, it's not a fact. It's only theory. A normal cycle is this: make a guess, measure, find the hotspot, fix it, measure again. Without measuring again, you can't call the optimization successful. Otherwise, you can spend time on a nice looking change that changed almost nothing, or even made something worse somewhere else. Pathfinding has already been moved to a separate thread. Roughly speaking, it's a separate pathfinding server. The main thread doesn't build the path itself, it sends a request. The pathfinding thread processes the queue and returns the result later. This matters because pathfinding can be expensive, especially when there are many NPCs. But the fact that there is a separate thread doesn't solve all problems by itself. If there are too few requests, the pathfinding thread sits idle. If there are too many requests, the queue grows, results get old, and NPCs can wait for a path they no longer need. So, next to the pathfinding thread, we need back pressure and a fill policy. Back pressure is a mechanism that doesn't allow us to send more work that the downstream part can process. Feed policy is a policy for sending requests. It decides what we need to the pathfinding thread: urgent requests, normal requests, local requests, global requests, repeated requests, budget requests. For example, escaping from a thread is more important than regular wandering. If a rabbit is running away from a wolf, its request shouldn't sit in the same queue as background tasks with the same priority. When threats appear in the world, we can't process all tasks the same way. Regular wandering can wait. Planet food search can also wait a few frames. But if there is a wolf, an enemy fire, or another critical situation nearby, the NPC should get a chance to react faster. For this, we need urgent queues. The point isn't to do everything urgent instantly. The point is that the system should have priority. Danger, fear, critical thirst, or another important state should go before background tasks. These let us keep control over the frame budget, but avoid an NPC reacting to a threat too late just because the queue was full of normal behavior. The more caches, queues, and derived structures a system has, the higher the risk of desync. For example, an object exists in the world but isn't registered in the spatial index, or an object was deleted but a reference to it stayed in a cache, or a dead body has already spoiled but someone still sees it as a fresh meat, or an NPC received a path to a target that already changed state. Rules like these can't live only in our heads. We need invariants, asserts, unit tests, and automatic resource checks. An invariant is a rule that must always be true. If an object is registered in the spatial index, its position in the index must match its current position. If a provider is marked as a water source, its profile must be correctly described in the resources. If a system expects a certain set of threads, they must be checked. This is especially important for NPC behavior because a bug can appear not in one method, but at the connection between layers, perception, needs, spatial index, caches, queues, navigation, and movement. The next layer is stamina. I don't want running to be just another speed mode that can be kept forever. Running should spend a resource. A burst should be strong but short. A long chase or a long escape should lead to fatigue. This matters for the wolf, the rabbit, and future animals. Every species can have its own profile. Some handle long effort better, some are stronger in a short burst, some recover quickly, and some take a long time to recover from fatigue. Sleep and rest become part of NPC physiology here. At rest, stamina slowly returns. During sleep, recovery can be faster, and accumulated fatigue can go down too. This creates a daily rhythms. An animal doesn't just run around the map all day and all night. It eats, drinks, moves, gets tired, looks for a safe place, rests, and recovers. The next important layer is basic memory. An NPC shouldn't live every time as if it just appeared in the world. If a rabbit has already found water, food, or its burrow, it can remember these points. Then, when it's thirsty, it doesn't only search for water around it, it can also try to return to a known place. For a wolf, memory can work differently. It can remember areas where it often saw rabbits and check those places more often during a hunt. Here, the spatial index and the memory solve different tasks. The spatial index answers the question, what is nearby right now? Memory answers the question, what does this NPC already know about the world? This is an important step toward behavior that looks not like random wandering, but like gaining experience. If we put everything together, we get a behavior pipeline. First, the NPC gets information about the world. What is nearby, whether there is a resource, whether there is a threat, whether there is a known point from memory. Then the needs and utility system evaluates what matters most right now. Drink, eat, run away, rest, look for a burrow, or continue normal behavior. Then the decision layer chooses an intent. The behavior tree runs a specific strategy, and locomotion turns it into movement. It's important that every layer is responsible for its own part. The spatial index shouldn't decide that the rabbit wants to drink. The utility engine shouldn't move the character directly. The behavior tree shouldn't open all world caches. Locomotion shouldn't know every reason why an NPC went somewhere. This kind of system is easier to grow, profile, and fix. In this version, the first visible parts of the future ecosystem are already there. There are rabbits, wolves, resources search, reaction to threats, spatial index, caches, and dirty flags. There is movement, visual flip, grass, surface textures, and tiling. But there is still a lot ahead. Next, I need to improve hunting and an intercept point, stamina, sleep, recovery, NPC memory, and smell. I need to develop dead bodies as a resource providers, meat, hide, bones, spoilage over time, and different consumers of these resources. I need to slowly cover ecosystem niches, wild animals, domestic animals, herbivores, predators, scavengers, and connections with human and farming. And at the same time, I need to watch performance because the goal isn't one pretty rabbit on screen. The goal is a world where there are many such creatures and they don't just stand there as decoration. That's all for now. In this iteration, I wanted to do two things. First, improve the visuals a little so the world is nicer to watch not only for developers but also for players. Second, move the internal NPC architecture forward. Spatial index, providers, caches, dirty flags, queues, metrics, pathfinding threads, and the first shape of the future ecosystem. On screen, this may look simple. A rabbit runs, a wolf nearby grass, surface movement, but under that, layers are already appearing, and without them a big simulation would fall apart fast. If you're interested in where the project is going, links to Patreon and Boosty will be in the description. Support isn't required, but it helps me spend more time on the game, devlogs, and technical breakdowns. Write in the comments what you would like to see in more depth. The spatial index, utility engine, wolf hunting, stamina, NPC memory, smell, or the pathfinding server. Thanks you for watching. Bye.